China just built a car that processes information 5 times faster than Tesla, drives farther than any European hybrid, and costs less than a BMW 5 Series. Nobody in Stuttgart saw it coming. Nobody in Munich has an answer. And the worst part for Europe? This is only the beginning. In 2010, Geely bought Volvo from Ford for $1.8 billion. The financial press called it a bargain. They were right, but completely wrong about why. Volvo wasn't a brand. It was a 50-year archive of European safety engineering, crumple zone mathematics, structural metallurgy refined across decades of cold-weather crash testing, passive restraint architecture that took billions to develop. Geely didn't buy a car company, they bought a library, and immediately started reading. Then came Lotus, not the brand, the DNA, the suspension geometry philosophy that Colin Chapman built by obsessively removing every unnecessary gram from a race car until what remained was pure mechanical logic. The understanding that handling is not about power. It is about the precise conversation between tire and road. Then Polestar. Then Zeekr. Each acquisition adding another layer to what was quietly becoming the most dangerous technology stack in automotive history. Western analysts called it portfolio diversification. Reasonable-sounding words. Catastrophically wrong interpretation. What Geely executed was a total technology extraction operation. Systematic, patient, devastating. And by the time Western boardrooms understood what was happening, the operation was already complete. BMW sources software from one supplier, battery cells from another, chassis tuning from a third, 3 companies, 3 engineering languages, 3 R&D timelines that never fully synchronize. The result is a vehicle that feels designed by committee, because it was. Geely owns the entire stack: metallurgy, silicon, software, suspension geometry, everything under one roof, moving at one speed. A speed Western manufacturers have no structural ability to match. For 30 years, the automotive industry operated on a silent lie, the lie that complexity equals capability. A modern German luxury sedan runs over 100 individual electronic control units, separate chips, each handling one function, communicating over copper wiring that weighs as much as a grown adult. One chip manages ABS. Another controls fuel injection. A third exists solely to stop the infotainment screen from freezing on the highway. This architecture was cutting edge in 1994. In 2026, it is a structural liability. Every additional ECU introduces data latency. Every meter of copper adds unsprung weight. Every communication handshake between chips creates a failure window. This is not a software problem. It is an architectural problem. And it is the precise reason legacy automakers cannot build software that actually works. The Lynk & Co 10 Plus eliminates this architecture completely. At the center of the vehicle sits the NVIDIA Drive Thor platform, a single unified brain processing 700 tera operations per second. For context, Tesla's Hardware 3, powering one of the most advanced autonomous systems on public roads today, processes 144 TOPS. The 10 Plus doesn't close that gap. It multiplies Tesla's number by nearly 5. The LiDAR arrays, millimeter-wave radars, and stereoscopic cameras generate gigabytes of raw telemetry every second. Thor absorbs that data ocean and simultaneously manages traction control, battery thermal regulation, suspension damping, and powertrain coordination. In one continuous stream, without hierarchy, without latency. When sensors detect traction loss, the system corrects torque vectoring before the human nervous system registers anything has changed. The car is not reacting to physics, it is running ahead of physics. Look at the spec sheet, and the engine catches your eye first. A 1.5-litre turbocharged unit. Unremarkable on paper. Then you see the thermal efficiency figure, 46.1%. Toyota has spent 2 decades and billions of dollars chasing efficiency above 41%. Honda's latest hybrid architecture peaks at 41.5% under ideal laboratory conditions. Geely crossed 46.1% by abandoning the conventional Otto cycle entirely, replacing it with an aggressive Miller cycle using extreme compression ratios and valve timing precision measured in microseconds. That number is genuinely extraordinary. It is also almost beside the point, because the thermal efficiency rating is not the breakthrough. It is a byproduct of the actual breakthrough, the North Thor AI Hybrid 2.0 system, and the philosophy that separates it from every hybrid ever built before it. Every hybrid system before this one is reactive. And you press the accelerator. The computer reads the input, calculates the load, decides whether to engage the combustion engine or draw from the battery. That sequence, however fast, introduces hesitation, and hesitation wastes energy. North Thor AI 2.0 eliminates the sequence entirely. The vehicle doesn't react to the road. It predicts the road, miles before the car physically reaches it. The system continuously cross-references high-definition topographical mapping with real-time traffic data, calculating gravitational load, aerodynamic resistance, and rotational inertia requirements for terrain that exists only in the future. When the AI detects a sustained incline 3 miles ahead, it pre-engages the combustion engine, locking it precisely into the RPM range where 46.1% efficiency is realized, before the gradient ever touches the accelerator pedal. The electric motors spool simultaneously, building a torque curve that meets the road's resistance before the resistance arrives. Every molecule of fuel, every stored electron, deployed not in response to reality, but in anticipation of it. This is not a more efficient hybrid. This is a fundamentally different category of machine. 2.2 tons moving at high velocity generates torsional forces that would compromise a conventionally engineered chassis. The GEA EVO platform answers with gigacast aluminum structures reinforced with ultra-high-strength boron steel. A passenger cell with rigidity that behaves less like a vehicle frame and more like a precision instrument housing. The suspension translates Lotus's racing philosophy directly into a production sedan. Double wishbone front. 5-link independent rear, chosen specifically for their ability to maintain precise wheel geometry under dynamic loading. The same configurations Chapman proved on the track, now managing 2.2 tons at motorway speed. Passive geometry alone cannot neutralize that physics. The active hydraulic damping system handles what geometry cannot. In a high-speed corner, hydraulic pressure in the outer dampers increases instantaneously, keeping the chassis geometrically flat as lateral G-forces load the outside wheels. Over broken road surfaces, those same valves open completely, absorbing shock before it reaches the occupants. Aggressive lateral control, absolute vertical compliance. 2 contradictory demands, resolved simultaneously, continuously. Then there is the cabin, where engineering becomes almost philosophical. A high-performance PHEV generates acoustic violence from 3 simultaneous sources. Electric motors spinning past 15,000 revolutions per minute, high-voltage inverter switching noise, and combustion engine drone from the generator unit. Legacy manufacturers respond with asphalt sound deadening, heavy, primitive, effective only at low frequencies, and catastrophic for overall efficiency. The 10 Plus deploys acoustic metamaterials instead. Structural composites engineered at the microscopic cellular level to physically trap and neutralize specific sound wavelengths, tuned precisely to the acoustic signatures of the vehicle's own inverters and tire cavity resonance. Not generic absorption. Targeted elimination. The 23-speaker Harman Kardon system reinforces this passively, continuously emitting inverted sound waves that destroy residual engine drone before it reaches the human ear. The result is not a quiet cabin. It is silence built with the same engineering precision as the powertrain beneath it. For 5 years, Western governments and automotive executives repeated the same narrative with the confidence of people who have never been wrong before. The plug-in hybrid is a compromise, a bridge, a temporary accommodation until full electrification makes it obsolete. The Lynk & Co 10 Plus is not a response to that narrative. It is a verdict against it. 1,400 kilometers of combined range, eliminating the charging anxiety paralyzing EV adoption across North America and Australia. 46.1% thermal efficiency, surpassing every hybrid benchmark Western engineers have publicly committed to reaching. 700 TOPS of predictive intelligence, 5 times the processing power Tesla currently deploys on public roads. Legacy automakers cannot close this gap quickly. They cannot replicate nor thaw AI without rewriting their entire software architecture from scratch. They cannot match the chassis refinement without dismantling supplier relationships that define their manufacturing model. They cannot synthesize Volvo's safety engineering, Lotus's suspension philosophy, and Zeekr's electrical architecture, because they don't own any of it. Geely does. The question is no longer whether Chinese automotive engineering has arrived. That question was answered the moment this car left the factory. The real question, the one nobody in Stuttgart or Munich wants to answer, is this: what exactly has Europe been building for 20 years? And why does none of it matter anymore?